All right, so good day. So today we will start a new lecture entitled Curvilinear Translation. So we've done with the linear translation. Okay, we've already had discussions on that. You could review the materials that I already sent to your group. Okay, so let's start with the idea or concept of curvilinear translation. So this is the fundamental concept. No? In curvilinear motion, the displacement vector will change in both magnitude and inclination. Now, the concepts of velocity and acceleration must be extended to include both these changes and displacement. So as you could see here in figure 3.1, okay, we could actually have the equations, no? You already noticed that there are equations that you could notice coming from the figure. Okay, so here we could say that S is equal to X, no, plus the horizontal displacement of Y. Okay, so we have that V is equal to ds over dt. Okay, so you could still remember that, no, from our previous discussion. And A, or acceleration, is the first derivative of velocity with respect to time. We obtain the equation, no, 3.2, which is the velocity is equal to v sub x, okay, plus the horizontal component of v sub y. Okay, and the acceleration is a sub x plus the horizontal component of a sub y. Okay, that's the concept of the fundamental concept of the curvilinear motion. Okay, so from that equation, aside from the um, distances, velocity, and acceleration, we can also have the displacement. Okay, so here from that figure, now let point A and B represent successive positions of a moving particle after elapsed time delta t. Okay, so this is the one that they are pertaining to. Okay, this point, okay, the point A and point B. So the change in the displacement, okay, or what we call delta S, during the interval time is the chord distance, no? The chord, this one, okay, this is the delta S, as you can see here, no? This is delta S, the chord distance, okay, between A and B. So if the change in displacement delta S is resolved to component parallel to the reference axis, the geometric relation between delta S, delta X, and delta Y will be given as this one. So in short, that is that the same thing with velocity and acceleration. That is, delta S is delta X plus the horizontal component of delta Y. Okay? Or dividing by the elapsed time delta T, okay, we could have this one, okay, up until we have this equation 3.2 wherein, no, we could derive that ds over dt is equal to dx over dt plus dy, sorry, horizontal component dy over dt, or the same thing as the velocity, no, yung kanina. Okay, that is vx plus the horizontal component of v sub y. Okay, ito, the same thing with this equation, no, magkamukha sila. Okay, because of the introduction of our elapsed time delta t. Okay, so another one. Okay, so we have this for the velocity. Okay, let's consider how about this figure naman. So the magnitude of the velocity is given by the algebraic equation. So we know this from your trigonometry, I guess from your calculus as well, that v is equal to v sub x squared plus v sub y squared, or the same thing applying with Pythagorean theorem, because we will have this formulation of right triangle. Okay, nakita niyo ba yun? Yan, so this is v sub y. I think this is the same, no? Ito rin yung v sub y, this is v sub x. So v is the square root of the sum of the squares. Okay, its direction with the x-axis by tangent theta x. No, the same thing also with the idea of your forces from your statics of rigid bodies, that tangent theta x, in this case naman, if it is velocity, v sub y over v sub x. So replacing v sub y and v sub x by the corresponding values d sub y over dt and d sub x over dt respectively. So we have that tangent theta x is dy over dx. Okay, so that means that the dy over dx, or the slope is the slope of the curve path. That's why when we have this parabolic curve, if you still remember, with your engineering data analysis or calculus, now we get the strip, no, of your curve, no, or the slope, and then, no, in getting that strip, no, and applying the equation, or should I say in differentiation dy over dx, therefore that is the slope of your path. Okay, so that means, no, the velocity is tangent to the path. Now that is the slope uh of the curve. Okay, so now let's discuss the horizontal components, or what we say rectangular components of acceleration. Okay, so in this case, as you could see in figure 3.3, this one ay nasa taas. Okay, so velocities at positions separated by A and delta t. Yan. So, shows that the continuous velocities at point A and B, which are separated by time interval delta t. If these velocities will be represented as free vectors as shown, so pinalitan natin because we are pertaining to rectangular components, as you could see here. Yan. So, it is evident that the vector of magnitude delta V and the direction indicated must be added to V sub A and V sub B. Okay? So, ayan po, nakikita natin, no, with that component. Okay? So, from that, we could have this equation. So, i-resolve natin yung delta V into component parallel and reference axis. So, just like kanina, diba, we have this velocity is V sub X plus horizontal component V sub Y. Therefore, yung ating delta V is delta Vx plus horizontal component ng delta Vy. Okay? So, dividing this relation by the elapsed time delta t, we could have actually dv over dt, no, that is because delta v over delta t, plus dvx over dt plus horizontal component dvy over dt, or remember, a is equal to dv over dt, therefore this is acceleration is equal to a sub x plus horizontal component of a sub y, which is similar to what we have shown kanina. Ito po. Yan. Equation 3.3. Okay? So, pinakita natin saan nanggaling or what, where we're going to use, or the concept that we could use to find the value of the acceleration. Okay? So, ayan po. And then, okay, so, from that, we could also get, no, the acceleration from the concept of Pythagorean theorem also. Okay, so a is the square root, or sorry, the sum of the squares of the component acceleration. Okay, ax sub x squared plus a is a sub y squared. Okay, yung kanilang square root. Okay, then we could have the tangent theta x, no? Kanina theta y. So this time theta x is a sub y over a sub x. Actually, that's also theta x, now with respect to your x-axis. Okay, so we could also have that, no, if we replace this theta y, a sub y and a sub x with d squared y plus dt squared, because that is the second derivative, remember, acceleration is the second derivative of your displacement. So, therefore, we have that tangent theta x is what? D squared y plus over d squared x. Therefore, the direction of the acceleration vector is not tangent to the path. Nasa ilalim. Sabihin, nasa ilalim yung kanyang, kanyang direction ng acceleration mismo, itong A. No? Hindi, unlike kanina, doon sa velocity nandito, pag ganito siya, di ba? So, this time, the acceleration is somehow below the curve. Kasi when you look at the integration or the double integration, no, nasa squared siya, sabihin, pangalawang beses mong kinuha na ng strip. So, malamang, nasa loob na yon or nasa ibabaw na ng curve. Nasa ilalim ng curve, unlike with the velocity na nasa ibabaw. Okay? Or tangent siya dun sa inyong curve. Okay? So, with in line with that, so we could have the what we call flight of projectile, or what we call air resistance is neglected. So I know that some of you are somehow familiar with this one, no, the projectile, with your previous discussions on calculus, and somehow with your STEM strand, no, you're more on the mathematics part or science related subjects. So we have the component velocity. We know that from projectile, v sub x is v sub o, initial velocity, cosine theta. Ito po, nakikita nyo from your left side ng inyong screen is the projectile illustration. Okay? So v sub 0, sorry, v sub o sub y, that means the vertical component of the initial velocity is v sub o sine theta. Okay? At any time t, the horizontal distance covered by the projectile is this one. So the same with yung x component natin actually is somehow the same with the application in yung linear, but with consideration this time, since it's projectile, we have this what we call angle of what? Inclination, because it is positive from the positive x-axis, no? The angle of inclination, or yung ating angle, okay? So also at any time t, the projectile should be at point E, okay? So however, because the action of the gravity, the projectile will go down at point D, okay? The vertical distance covered with the projectile is eto na. So, bakit ganon? No? Somehow, no? We expect, no, when we throw something at a certain angle, we believe that the position, no, without the action of the gravity, okay? So, dediretso lang, just like this one, no? Sa point E. But because we have this action of gravity, mapupunta lang siya dito. Okay, sa point D. Bababa. Now, that is the y distance actually. So, from your equation, from linear motion, okay, or linear translation, pero this time, no, we change it or apply it in the projectile application, or should I say the vertical component. Okay, kanina yung x natin is v sub ox multiplied by t, or vt, but this time, but we have also to apply the theta, so that we v cosine theta t. In this case, your y is v sub oy multiplied by t minus, because what? Ano siya? Because of the gravitational constant, no, na bababa, no? Kumbaga parang hinihila pababa, tama? So, minus 1/2 gt squared. So, and v sub y is with the application of sine theta. That's why it is v sub o sine theta t minus 1/2 gt squared. Okay? So, the same thing, no? So, kung i-apply natin lahat, no, with the application up until sa ating x max and y max. Actually, the x distance maximum is the range. So, yun yung total na tinravel. But, the y distance is what? 1/2 time ng flight, okay? No, from A to B, no? Ito 'yon. From point A to point B, we have this maximum y distance, or that is equal to v sub 0 squared, ito na lang, sine squared theta over 2g. Ito yung kanyang derivation, okay? So, since alam natin yan na yung ating time is v sub o sine theta over g coming from this one, no? Applying what? That the time is ito, no? Parang lumalabas siya na 0 yung ating yung ating y, 'di ba? Lumalabas na 0 yung ating y at time t. Ibig sabihin hindi na siya gagalaw doon, parang maximum point. Okay? So, ito 'yon, hanggang sa dinerive natin siya. Ayan yung ating formula. Okay? So, ayan. So, we have also the maximum, just like I've said, no, yung ating maximum horizontal distance, ito tawag natin na range. So, that is equal to v sub o squared sin theta cosine theta over g, or simply v sub o squared sin 2 theta g. Okay? So, yun yung pinagkaiba nila. Yung ating y max is v squared sin squared theta over 2g, but yung ating x max, or the range, is v squared sin 2 theta over g. So, this is the comparison, no, ng ating mga rectilinear motion in line with your projectile. Itong table 3.1. Ayan. So, napapansin nyo, mukhang magkamuka, pero we have also to consider yung yung ating mga theta component. Okay? So, ayan. So, ito po, no, kapag ganito yung kanyang application, ayan, no, lumalabas na parang nasisimplify natin. Okay? Sige. So, for us to get into that, no, to apply that, let's answer this problem. Yan. Sabi dito, a stone is thrown from a hill at an angle of 60 degrees to the horizontal with an initial velocity of 100 feet per second. So, I think this is the 60 degrees. Ito. Ito siya. Yan. So, after hitting the level ground at the base of the hill, the stone has covered the horizontal distance of 500 feet. How high is the hill? So, ang tinatanong sa atin, yung taas, no? I think this y value, yung tinatanong, no? Kasi, that is from your elevations of x, or x distance from another x datum, no? Papunta na sa hill. Yan. So, yan yung tinatanong sa atin sa problem. And for us to solve that, kailangan natin munang tignan yung mga given or possible na given. So, we have here that the theta is 60 degrees. Ano pa binigay sa atin? I think meron tayong given na 500 feet daw yung distance kung saan babagsak, no, yung ating ball or stone rather. Ito, binigyan tayo ng x distance na 500 feet. Yan. So, meron tayong 500. Ano pa? Binigyan din tayo ng velocity. I think the initial velocity was given as 100 feet per second. Ayan. No? 100 feet per second. So, we could actually solve directly actually from our equation. No? Pwede na. We could actually direct substitute, no, the values of our given to the equation na binigay sa atin. So, first, let's compute for the x or the time with respect to your x distance. So, what is the equation? That is x is equal to v sub 0 sub x cosine theta t. Ito yung ating vt, no? In consideration do sa ating theta. So, therefore, time, you could actually derive that time is v sub o sub x cosine theta. O, substituting this, no, to our equation. Anong equation yon? The y equation. So, that is y is equal to v sub o sine theta minus 1/2 gt squared. O, yan. You could actually substitute this one papunta dito sa equation na to. Okay, so, by substituting that one, okay, so, punta tayo sa medyo blank na space. So, let's rewrite the equation again. So, that is y is equal to VO sine theta multiplied by, I think, let's write this one, time minus 1/2 gt squared. And we say kanina from derivation that time is x over v sub o cosine theta. Okay. So, substituting this one, no, that is y is v sub o sine theta. Yung ating t ay x over v sub o cosine theta. Yan. Minus 1/2 g, that is x over v sub o cosine theta squared. So, simplifying this one, you could actually have, no, ito makikita natin that sine over cosine is tangent. Tama ba? So, we also have, no, pwedeng hindi na natin masyadong galawin yung mga 1 over cosine squared. Let's leave it as it is kasi mukhang mas madaling pindutin sa calculator, mas madaling ma-solve. So, let's simplify this one. VO, this is sine over cosine is tangent. So, lumalabas VO or simply what? Ano to? X tangent theta. Tama ba? So, that is lumalabas na X tangent theta because we have this velocity na, no? Okay, that is X multiplied by VO is what is x or y na, no? Ayan. So, lumalabas ito na x tangent theta. Okay, so try lang natin. Ayan. BO tangent theta multiplied by x, tama ba? Minus, yan. Actually, maka-cancel na pala, no? Ito. Yan, multiplied by g x squared over 2, tama ba? V sub o squared cosine squared theta. Or, yun nga, y is equal to x tangent theta minus ito. Yan, gx squared over 2 b sub o squared cosine squared theta. O yan. Ito yung equation na gagamitin natin to solve, no? Kasi mukhang kailangan lang kasi y eh. So, from that, edi direct substitute natin. Okay, so, let's rewrite the equation that is y na mas maayos ng konti. X tangent theta minus, okay, so, nakikita itong denominator para medyo maganda isulat. 2b sub o squared cosine squared theta. Yan yung ating denominator. At yung numerator natin galing dun sa pag-simplify na equation is dx squared. So, direct sub, no? Ano nga ulit yung mga given natin? We have the given theta 60 degrees. Tama. We also have that x as 500 feet. And yung ating v sub o is 100 feet per second. O yan, direct substitute tayong lahat dito sa problem na to. Y is equal to 500 multiplied by tangent theta minus, so we have that G, no, alam natin na ito ay 32.2 feet per second squared kasi tayo gumagamit ng feet per second na velocity multiplied by x na, ano to, 500 squared, yan, over 2 multiplied yung ating velocity na 100 squared, then cosine squared 60. Okay, so simplifying that, we will arrive with the answer na 743.975 feet. O yan, ganyan daw kataas, no? Yung ating hill. Ito yung ating answer for this problem. Okay? So, first, okay, let's have a little recap. No, we derive the equation, this one, no, ito yung ating y, coming from two basic equation, o yung baseline equation natin. Ano nga ulit yun? Ito, yung x equals to v sub o x cosine theta t, and y is equal to v sub o sine theta minus 1/2 gt squared. Okay? So, from that, no, we arrive from that equation, we arrive from this one, no? Dinarive natin siya, sinasitute natin, and so on, hanggang sa na-derive natin itong formula na to na ginamit natin to solve for y. And this is our answer. Ito po, ang answer natin for this problem. Okay? So, going back with the illustration, so lumalabas pala, ito ay nasa 743.975. O, ganyan kataas yung hill, assuming na nag-throw ka ng stone at bumagsak at to this point na may distance na 500 feet measured, no, from the point of reference mo dun sa hill. Siguro mula sa sahig ka, no, bumato, parang nakahiga. Kasi pag ina-analyze mo yung problem, kung elevation niya pag-uusapan, di ba pag bumabato ka, dapat may height ka pa, no? Pero dito, sa problem, parang assuming na nakahiga ka nung binato mo, parang ganun, no? Or parang dikit na dikit yung inyong kamay, no, dun sa surface ng hill, no? Parang ganun. Pero, nevertheless, no, that's the approach on the problem. Ngayon, kung may madadagdag ng height, of course, idadagdag yon dun sa inyong problem, no? So, idadagdag siya. So, masyadong tedious, no? Hindi na natin pag-usapan. Ang problema lang naman natin dito, yung height lang naman ng hill. At mukhang solvable naman using the equations ng ating curvilinear motion. Okay? So, that's our first sample problem. So, we have this one, no? Nakalagay sa kanya 3.4, but this is our second sample problem. It states here that the boat A moves with a constant velocity of 20 feet per second. So ito daw, ayan, nakikita nyo sa illustration nyo from the somehow right side of your screen. Yan, so nakalagay dyan, no, from the position shown in the figure, find theta for the projectile to hit the pole 5 seconds after starting under the conditions given. Yun yung binigay. Now, how high is the hill above the water? So, lumalabas, parang kailangan natin mahanap yung value ng S, no, na nakikita nyo dito. You should find this one. And then, from that, we could solve this y distance. Why? Because we cannot solve this one without this, no, parang kung saan tatama doon sa point na yon. Kaya yun yung sabi dyan, di ba? Find theta. Also, we are required to find this one, no, to hit the boat 5 seconds after starting. Parang may magbabato daw, no, na kung ano man at tatamaan yung bangka, no? Kung ano man yung ibabato doon at given yung velocity na to na 96.6 feet per second. So, hindi ko alam kung ano yon. Baka may nakalimutan tapos ibabato sa ganyang kabilis na velocity yung nakalimutan na gamit at mukhang tatamaan niya yung bangka. Siguro masasalo. Parang ganun. Okay? So, let's try to analyze the problem as it is muna, no? As plain as it is. So, from here, yung S distance, we could actually solve, no? The S distance, no? From the simple linear equation or linear translation. So, S, we know that displacement or distance is velocity times time. Tama ba? So, meron tayong given na velocity. Meron ba tayong binigay? I think meron. We have that constant velocity of 20 feet. Ayan, no, nakalagay po. Multiplied by, ang sabi dito sa problem ay 5 seconds daw tatamaan yung ating bangka, kung anumang projectile yon. So, multiplied by 5. So, lumalabas yung ating S distance pala ay 100 feet. O, yan. Na-solve na. No? Kung 100 feet yan, therefore, etong distance na to, no, ayan, yung total distance na to pala, ay 100 plus 301 nakalagay. This is 401 feet. No? So, that is 401 feet. So, from that, we could actually solve the theta. Tama ba? Because we have the equation of our curvilinear motion. Ano nga ulit yon? Yung equation ng ating curvilinear motion. From the rectilinear, di ba? That is Vx multiplied by time. Di ba? Or S, di ba, is Vt. But this time, yung X natin from this illustration, ayan, mukhang that is, gamit yung ating theta. So, X is equal to Vox multiplied by cosine theta T. So, since given na sa atin yung ating X distance na 401 is equal to Vox, ano nga ulit yun binigay sa illustration? 96.6 feet per second square, feet per second multiplied by cosine theta multiplied by time na 5 seconds. Yun kasi required. So, from that, we could have the value of theta as 33, yan. So, 33.878 degrees. So, ito pala ay 33, yan, 33.878 degrees. Okay? So, from that equation, okay, so meron tayong theta, no? Saan natin ulit nakuha? So, we computed for the value of S using the linear translation at mukhang meron, possible, right? So, from that, in-add natin to doon sa natitirang distance daw kung saan naman gagaling yung projectile papunta sa boat na binigay na 301 feet. Ngayon, sa problem, binanggit na 5 seconds after batuhin, kung ano man yung projectile na yon, tatamaan yung boat. So, that is the theta required, no, na pinapahanap sa atin. Ano yung X distance? Yung S distance sa tinravel from that point A, let's say, to a projectile point, kung saan bababa, plus the 301 feet distance. Okay, so kaya na-compute natin yung theta. Ayan, may answer na tayo for our theta. Ito na. Now, the next is yung height ng hill. Okay, balik tayo dito sa illustration. So, pinapahanap na naman sa atin yung height naman ng hill. Okay, so mukhang assumption ay bumato ka mula sa sahig. Parang ganon. Kasi, sabi ko nga, pag ganito, dapat kino-consider din yung height ng tao. Pero, dahil mahirap yon at mukhang maraming kailangan pagdaan ng mathematical consideration dahil may height ka to a certain height, no? Yung height pa ng kamay mo nung binato mo. So, mukhang consideration ay sahig at mukhang binigyan naman tayo ng ganung setup. So, from this, no, I can actually solve with the y, no? With the equation ating curvilinear motion, ano nga ulit yun? That y is equal to, kung kanina, galing sa vxt, no? Parang ganito lang siya, no? Vt, tama ba? Naalala niyo po ba to? Vt plus 1 half gt squared. Yun nga lang, no? Hindi magiging plus dahil ito ay projectile. So, negative to. Itong v natin, na tinutukoy yung initial velocity ay magiging in consideration dun sa ating theta. Kaya lumalabas yan, y is VO sin theta t minus, kasi projectile di ba? 1 half gt squared. O yan. Binigyan tayo ng time na 5 seconds. Meron na tayong theta na 33.878. We have also the initial, or the initial velocity or v sub 0, no, na 96.6 feet per second, o direct substitution to lahat, no? We have this 96.6 sine 33, yan, 0.878 multiplied by 5 minus, ito na lang, 1 half g na 32.2 dahil ito ay naka-feet per second o yung mga velocity ay naka-English multiplied by 5 squared. So we have the value of y in feet as 133.264. Ayan. So this is our answer for this problem. So ano nga ulit yun? Na pinapanas natin na required yung theta kung saan yung ating projectile. Let's go back to the illustration na ma-meet niya yung time na 5 seconds bago tamaan yung boat and the y distance, no? Na yung hill, yung height ng hill from what? Doon sa ating kung saan man, no, yung ating projectile na distance, ito, no, dito. Actually, ito yan, yung y na yan. Ito lang yan. Okay? So, ayan po. Okay? So, that's it for our first part. Actually, this is the first part of our curvilinear translation. Okay, so, we will go with the second part, and then, as we go along, we will notice that we have this application after application of the fundamental concepts of curvilinear translation. Okay, so this is the first part of the curvilinear translation with their fundamental concepts.